Rounding intermediate results with IEEE 754 half-precision floats. Floating-point arithmetic is critical in computing, enabling a diverse array of calculations in scientific, engineering, and financial applications. One of the common challenges is adding floating-point numbers, particularly when using IEEE 754 half-precision floats, which are constrained by their limited precision. IEEE 754 half-precision floats. The IEEE 754 standard for floating-point arithmetic defines a half-precision, 16-bit, single precision, 32-bit, and double precision, 64-bit, format. The half-precision float, also known as binary 16, is made up of 1-bit sign, 5-bit exponent, 10-bit significand, including the implicit leading bit. With such limited bits to represent numbers, the significance of precise rounding during arithmetic operations becomes evident. Why rounding is important? Rounding intermediate results is crucial to ensure the accuracy and stability of floating-point computations. When adding two half-precision floats, intermediate results often exceed the precision provided by half-precision format, making it necessary to employ appropriate rounding techniques. Rounding techniques. Several techniques exist for rounding floating-point numbers, including round to nearest, ties to even, bankers rounding. This is the default rounding mode in IEEE 754. When a number is exactly halfway between two possible rounded values, it is rounded to the nearest even value. This technique helps to minimize cumulative rounding errors. Round towards zero, truncation discards the fractional part, effectively rounding towards zero. Round toward positive infinity, rounds the number up to the nearest representable value. Round toward negative infinity, rounds the number down to the nearest representable value. Practical implementation. When two half-precision floating-point numbers are added, the intermediate result might require full single precision representation to keep accuracy. After calculating the sum, convert or cast intermediate result to half-precision float, use appropriate rounding techniques. Implement rounding mode, utilizing hardware or software-based floating-point units. Example case. Consider adding two half-precision floats. Convert each operand to higher precision, perhaps single precision, for intermediate calculations. Perform the addition. Round the result back into half-precision format, using the round to nearest, ties to even strategy to mitigate rounding errors. Conclusion. Properly rounding intermediate results when adding IEEE 754 half-precision floats is essential for maintaining computational accuracy. By understanding and implementing appropriate rounding techniques, the precision of floating-point arithmetic operations can be significantly enhanced, ensuring reliable and predictable outcomes in various applications.